Okay, today we are going to discuss dielectrics and electric polarization. So dielectrics are basically a non-conducting substance called insulator also. So in case of insulator have a minimum number of free charge. Due to the minimum number of free charge distribution is not takes place within a insulator, but it shows electric effect. Okay, dielectrics made up of dielectrics are two types of dielectrics. One is polar dielectrics, another one is non-polar dielectrics. So let's discuss one by one. First of all, the polar dielectrics. Polar dielectrics in which there is a average separation between the positive charge and negative charge. I repeat again, in polar dielectrics, there is average separation between the positive charge and the negative charge. So here the water molecule is one of the example of the polar dielectrics. In particular, water molecules, the center of the negative charge is oxygen ion, and center of this particular positive charge is the midpoint to the line joining the two hydrogen ion. Okay, and there is a separation between center of positive charge and center of negative charge. Okay, so the center of positive charge and center of negative charge acts like a point charges. Hence, polar molecules behave as a permanent electric dipole. Polarization of polar dielectrics in an external field. Okay. In a polar dielectrics, polar molecules have a permanent dipole moment. Okay. So even absence of the electric field, polar molecule in a dielectric are such that their electric dipole moment are randomly oriented due to thermal energy, and therefore the total dipole moment is 0. Okay. Now here, when a dipole is placed in a uniform electric field, then it experiences a torque. Okay, and due to the torque, it rotates and aligns in the direction of electric field like this. I repeat again, when dipole is placed in electric field, then it experiences a torque and it rotates and aligns in the direction of electric field. So here, when a polar dielectrics is placed in an external electric field, then each dipole experiences a torque and it rotates and aligns in the direction of electric field. Thus, dielectric material with polar molecule is said to be polarized. Non-polar molecules are those which do not possess permanent dipole moment. In non-polar molecule, average center of positive and center of negative charge are coincide to each other. Hence, they do not possess electric dipole moment. Okay. CO2 is one of the example of non-polar molecule. In particular, CO2 molecule, center of the negative charge and center of the positive charge are lie at the same point. Therefore, CO2 molecules do not possess a permanent electric dipole moment. When a non-polar dielectric is placed in an electric field, then positive charge moves towards the electric field and negative charge moves away from the electric field. Means the separation of charges within the molecules, there are negative and positive charge are separated at some distance, and the negative and positive charge are separated at some distance, then electric dipole moment are created within the molecules. Okay, and the separation of charge occurs until the external force applied by the electric field is exactly balanced by the restoring force within the molecules, and hence it is said to be polarized in external electric field. reduction of electric field due to a polarization of dielectrics. Here simply a dielectric substance is placed in an external electric field. If a dielectric substance is placed in an external electric field, then positive charge attracted towards this particular negative charge and negative charge attracted towards this particular positive charge, and separation of charge occurs. Okay. And inside a dielectrics, due to a positive negative, positive negative, positive negative, positive negative cancels to each other, and inside a dielectrics the electric field is 0. And two opposite charges are induced on two opposite sides of the dielectrics. Okay. And this particular induced charge, it creates its own electric field called polarization field, and direction of electric field from positive towards the negative, and direction of this particular polarized field is opposite to that of the electric field. Okay. And magnitude of this particular polarized field is less than that of the external electric field. So we can write E dash is equal to E minus E0, E nothing but external field, E nothing but E0 nothing but polarized field or induced field due to induced charge produced induced electric field. Okay. So degree of polarization is directly proportional to the external field. We increase the external field, then separation of charge increases. So degree of polarization is directly proportional to the external field. The proportionality sign is changed. So P is equal to psi E into E. Psi is nothing but electric susceptibility. Therefore, psi is equal to P divided by E. P nothing but polarization vector, E nothing but external electric field, and is a dimensionless quantity.